Hello and welcome to Masters with Masters. I'm Ed Hoffman, the NASA Chief Knowledge Officer, and today we'll be focusing on the issue of knowledge and lessons learned across NASA. We have two distinguished guests with us today. We have Dr. Michael Bell, who's been leading a lot of the efforts for the Kennedy Space Center and is currently the NASA Chief Knowledge Officer at the Kennedy location. Michael, before the knowledge activities, has also served in leading a lot of the efforts around lessons learned for Kennedy, as well as the agency's lessons learned information system. And I welcome you, Michael.
Thank you. And
we also have David Oberhettinger, who is the Chief Knowledge Officer at the Jet Propulsion Laboratory. And David has also been working for quite a long time in terms of the exchange and the sharing of knowledge, particularly at JPL, but also as part of the agency efforts in terms of its policies and lessons learned. And he also steers different activities at JPL on engineering standards and on lessons learned and on engineering research. So I thank also you, David. And it's great to have both of you here. One of the things that we've been a part of for the last couple of years at NASA is the increasing importance on knowledge related to the missions that we do, the capturing it, the sharing it, and how it's discovered by our folks. And before we get into that, let me start with Michael. I've known for a long time, and both of these guys are friends. I've known you for quite a long time. How did you get to Kennedy Space Center, and how did you get involved in the work that you're doing? What are some of the experiences that you've had?
That's kind of an interesting story. A lot of people I know who work here dreamed about working for NASA and got a job right out of college, but my background is industrial engineering. And I actually was working at a factory that produced terminals for the Florida Lottery right out of school. And it was a cool experience because we kind of looked across the whole process flow to understand what was happening and make improvements. And eventually that project was completed, and I did get on to work here at NASA. But I started out as a management analyst looking at the staffing levels across the center, and still looking across the whole activity to try and figure out how we can make things better and allocate our resources properly. But eventually I did get into an engineering function and became involved with the Lessons Learned program.
Yeah, so supporting the effective engineering work that's done here, and without going into too much, the industrial engineering, what was it that you were trying to accomplish when you first got here in terms of that work?
The shuttle process was a big part of the case when I first got here, and industrial engineers were looking at ways to make things more efficient. But my role really was trying to figure out how we could allocate resources and make sure under the constrained budget situation that we were able to make it happen without going over. And that's a continuing challenge, making sure that we have the knowledge and the resources to make things happen and our budgets aren't getting any bigger.
So yeah, how do we do work, engineering work, technical work more effectively has been a common theme, and we'll get to how it translated into lessons learned shortly. David, working at the Jet Propulsion Laboratory, obviously a phenomenal organization. How did you get to JPL? And I know you came from Northrop Grumman, so what were some of your early key experiences?
Well, I joined JPL as a Northrop Grumman contractor originally in 1986 as a reliability engineer. And at that time, the lessons learned process was run by the reliability engineering office at JPL. Later it was transitioned to the office of the chief engineer, mirroring the transition at headquarters from OSMA to OCE. But in classical reliability engineering, failures are time dependent. Things just wear out. Here at Kennedy, you have launch platforms that are subject to saltwater corrosion, and if you don't maintain them, they'll fail at a more or less predictable rate. And at JPL, that wasn't really true. The failures were not time dependent, and lessons learned certainly had some pertinence to that. For example, early on, we had the Galileo probe. Galileo released a probe into the Jovian atmosphere. Reliability engineering, you speak of failures per 1,000 hours of operation, but the Galileo probe, as it descended into the atmosphere of Jupiter, sending back science data, was only designed to last for 45 minutes, less than 1 hour, before the atmosphere of Jupiter crushed it like a soda can. And it encountered 230 Gs of deceleration. And the heat shield protecting the electronics heated up to twice the temperature of the surface of the sun. So any failure modes are going to be practically instantaneous. And similarly with the Mars Exploration Rover, which has been in operation for over 10 years on the surface of Mars, but over that 10-year mission, perhaps 90% of the risk over the mission was in the last 7 minutes of entry, descent, and landing to the surface of Mars. So, we're in a cycle of constant innovation. We go from a Mars rover that uses airbags to land to the last Mars rover that uses a descent stage, that uses a sky crane that hovers off the surface of Mars. So we're going through all this innovation, but some things don't change. I mean, we're going to launch we plan to launch the next Mars rover in 2020. And in terms of most of the stuff that's done in project development, we're probably going to be conducting the same tests or similar tests, similar analyses that we performed 25 years previously on the first Mars rover. So if you're going to fail, if you're going to have failures during the mission, you want them to be new things.
Right.
You don't want to fail
Based on
on the
innovation.
things, yes, you don't want to fail with the things that you supposedly knew how to do. So lessons learned is a very vital way of capturing that sort of experience. Tests, analyses, and all those things you do, setting of requirements that you do over the life cycle of a mission. So at least you have those things down pat.
Yeah. And so one of the things also from the introduction, both working for NASA and obviously aerospace and missions and launch, but the differences become important from the standpoint of the time frame, whether something needs to be maintained over long periods of times or whether something's being experimental and innovative, and that obviously wraps around some of the approaches for knowledge and for lessons learned. Let me go back to Michael, and let's look at lessons learned and get some of the reflections. And so when I first met you, it was a while ago, and you were working at that point on a lot of the lessons learned activity for NASA. And I'd like to get maybe some of your thoughts and reflections on what was going on to at least get started in terms of the agency with lessons learned at NASA and your involvement in that. Where did we come from?
I think David talked about the initial part of the Lessons Learned program was connected with safety and mission assurance. When people thought about lessons learned, they usually thought about failures, and if something breaks, how do we, let's sit down and talk about what went wrong. But part of lessons learned is trying to learn from some success. But there was a mindset shift in order to say, let's focus on not only failures, but focus on success and broaden the connection from when something breaks to when we design something. So early on, the focus from mission assurance was expanded to the engineering project management side. So as project managers and designers are starting up a new spacecraft or a new design, they need to look to the past and look to other places for what can they incorporate into a design to make it better, to improve upon it. And that's been sort of a mind shift across the Lessons Learned program from the history of it, where it was mainly focused on when something broke, let's find out why and learn from it, to let's improve continually and let's put those new things in as we're designing stuff just from the start.
Right, and so putting more of a proactive spin as opposed to perhaps being seen as a negative where we're looking at problems. The bulk, it sounds like activities now is how do you proactively work towards making things effective in the future in terms of what's happened. Some of your thoughts in terms of lessons learned and that aspect of it, how we got started, I guess, as a community to a certain extent.
Yeah. Well, NASA, the Jet Propulsion Laboratory is the lead NASA center for the robotic exploration of the solar system. We've visited every planet except for Pluto, and well, we kind of fixed that.
Yeah, we made it not a planet, right?
Yes.
So we've been to every planet.
We've been to every planet. We sent 4 rovers to Mars. all of them successfully. I got involved in lessons learned as I said, the lessons learned process within the reliability engineering organization. I started off at JPL as a reliability engineer, so there was a need for someone to actually draft lessons learned, because the previous mode was to kind of wait for them to come in, and then once they dropped into your lap, then the lessons learned committee would process them, finalize them, wordsmith them. That isn't very effective if you're sitting waiting for a spider waiting for a fly to fly into the net. So we found at that time to be very effective to have someone actually drafting it. Also, you have some consistency in format and content, and so that was how I got into it. JPL has a culture of lessons learned. A couple of weeks ago, we had someone from the Skunk Works, the Lockheed Skunk Works, give a presentation at JPL, and he quoted Kelly Johnson, who founded the Skunk Works in 1958. Kelly Johnson, the famous aerospace pioneer, and he talked about that Kelly Johnson had gone to a visit to a U.S. ally in the Far East. He didn't want to give the name of that ally, but he talked about how the Skunk Works was formed and how very rapid prototyping and innovation, and when they had a problem, when something failed, they would quickly take stock of it, fix it, and go on. And after the presentation, one of the hosts came up to Kelly Johnson and said, well, we could never have a Skunk Works in our country. And Kelly Johnson asked, why not? And the fellow said, well, when we have a problem, when there's a failure, we find out the people responsible and we fire them. So,
I would cut it down on a little bit, sharing again.
So you're not going to have many lessons learned coming out of that sort of culture. But you have an organization like NASA and JPL specifically that's supposed to take on high-risk missions. If it's something like building a spacecraft bus, you give it to a contractor to do, because spacecraft buses have been done before. But if it's something new like a sky crane that's going to hover 100 feet off the surface of Mars, that type of system would be developed by JPL. You have to be accepting of risk, but you've got to capture the knowledge so that it can be used next time. Because if more than 5 years goes on between a Mars mission, using Mars as an example, we go other places too, we're going to lose that capability. And generally we do have a Mars mission every 5 years or so.
Yeah. Well, one of the challenges of a project-based organization that we've known for a long time is that people work on a mission, and when it ends, the first thing you want to do is you want to get to the next good work, because you don't want to be frozen out. So as opposed to an institution, kind of an organization where you're doing the same thing over maybe decades, you can accumulate knowledge in a project. The tendency may be not to do that. And so this is some of the things we're talking about. I want to get, I guess, both of your thoughts in terms of the evolving of lessons learned and what it is, and how it is today compared to maybe where we started it, a decade ago. And let me throw out, where are we today in terms of lessons learned compared to where we started probably a decade ago?
Today, I think we have a much more penetration into the project management and the engineering organizations, and we have a lot of diversity in the ways that we collect lessons. We acknowledge that. Previously, writing up a lesson and putting in the lessons learned database was thought of as the only method for lessons learning. Although we have lessons learned in our coursework, we have lessons learned. We've always had those things incorporated into the standards that we would do, but the thought about a lesson was this is a entry into a database. Now we're doing lessons learned in pause and learn sessions, we're doing case study discussions, we're doing lots of other ways that we know people learn and we share knowledge. And I think that is the future that we're going to, is recognizing that there is diversity in centers, the way they learn, and diversity in methodology, collecting and sharing. We're trying to capitalize, of course, on the technology that's out there, but we realize that that's not the only way that we do lessons learned.
Right. And I should mention we're here at the Kennedy Space Center with a wonderful audience, and we will take questions And so as you have questions, you can write them down, and Susan will pick them up, and I'll go to those questions shortly. So we've talked about in terms of lessons learned. One, it's more proactive than it had been, you both said. It's really about learning from successes as much and maybe more than from where things went wrong. And Michael, you talk about there are different ways, which seems to get into different fields of learning. It's not just about capturing it only into a system, but it's also about training. It's also about how people access knowledge and information, and its different approaches. Any thoughts on the evolution? Again, you've been a part of this community for a while. You've seen it change fairly dramatically.
Well, Michael's spoken on the NASA evolution. Giving it a center perspective, JPL has a very mature lessons learned process. We started in 1978 with what we called a spacecraft significant event file, which was a three-ring binder. And that was difficult. I mean, you had to distribute it to people's desks. The three-ring binder, you had to have the ability to update it, so you would send them sheets to put in. And but we had these spacecraft significant event file coordinators. And these coordinators started in 1984 to meet on a weekly basis, and that became the JPL Lessons Learned Committee. So we have a Lessons Learned Committee that's in operation today. In fact, I chair it, and it's been meeting weekly since 1984. In 1992, the Lessons Learned Steering Committee was formed, and so they had representatives from all the centers, and I was a representative from JPL. I believe you were from Kennedy. And that was very useful in that we could share lesson learning methodology between the centers. And then in 1994, we finally came up with an automated system that became what today is the Lessons Learned Information System. That's available throughout NASA, and there's a public version of it that's that's publicly accessible. And then in 2010, JPL realized that we needed to do more to make sure lessons learned got used, because you couldn't depend on, in the project development lifecycle, it couldn't depend on a proper person reading and acting upon a lesson learned at the phase of the project lifecycle when they could really make use of it. And so what we decided we needed to do was to not depend on people reading the lesson learned, but rather to infuse lessons learned into JPL procedures and training, such that we weren't dependent on someone having the volition to go to it. And so we have two documents that are really our engineering Bibles, our design principles and our flight project practices, which covers the engineering tasks other than design. And what we've done is, for example, design principles, there's about 300 requirements in that, of things that we always do from project to project. And at each paragraph, we've cross-referenced lessons learned to that. So projects have to do a compliance check against the design principles, and that gives them an opportunity to check the background of why we need to do that.
So obviously a lot of the knowledge and the learning activities have gone on for quite a while, and they've evolved from largely capturing the notes and having them in notebooks to much more proactive rigor. So Michael, you are the program manager for the Lessons Learned Information System. What do you see as the accomplishments of that? What are the things that are good about it? And what are the challenges that you see with LLIS?
I think one of the accomplishments that we're very proud of is being part of the NASA Engineering Network, so that when you look for lessons learned, you actually go to the NASA Engineering Network and you can see the list of communities of practice that are part of there for knowledge sharing. You can take advantage of the other resources. So the recognition that the database is one aspect, but peer-to-peer knowledge sharing is a great way to accomplish some of the lessons learned. We have the centers all contributing to the Lessons Learned database, and they're branching off into other ways that they capture knowledge. But the big accomplishment, I think, is tying into the engineering community, being part of the engineering requirements, and also the connection, as David said, back to the engineering standards, so that people realize the way we work and what we do is all tied into learning from some of the situations that have happened.
Right. And so one of the things I hear us saying is that while there was a lot of focus was on I guess, processes, writing them down and documenting the appropriate approaches, there's also an integration with technology, the database system, the lessons learned, approaches that make information readily available to people. But at the core, it's the people. It's encouraging the dialogue and the exchange and folks having a comfort level and a culture that encourages that kind of a discussion. Would you agree with that? The people, technology, processes kind of is what it's about nowadays, that integration and hybrid?
Yes, and the lessons learned information system certainly facilitates that sort of collaboration you're talking about. I recall you, Dr. Hoffman, mentioning once that NASA is arguably the best federal agency in terms of getting information out to the general public.
Well, I said it was the best federal agency, period. But yeah.
That within a center or even within a flight project, information doesn't always flow that effectively. For example, we have the Mars Science Laboratory that will prop the Curiosity rover, and we're planning, I mentioned in 2020, to launch a successor to Mars that will be pretty much build to print. It'll be very similar, except different instruments. It'll have a different instrument suite on it. So you would think that the Mars 2020 development team would have access to all the knowledge that was generated in developing the identical rover that's now on Mars. But on the other hand, in the course of Mars Science Laboratory, as with any project, the focus is on getting that system to launch. It's not, the first priority isn't retaining that knowledge for the next mission, because the project manager has a responsibility to deliver that to the customer, mission success.
Yeah.
So, one thing we've done at JPL is about a year ago, there was a memo written to our science and engineering directorate that lessons learned needs to be at the section level. So each section, a section at JPL corresponds to, I think, a division maybe here. It's generally where the technical disciplines are housed. So you would have a thermal engineering section, and you'd have a propulsion engineering section. At JPL, propulsion is little thrusters, things you have here that make a lot of noise. They're just little few new thrusters, yeah. But so yeah, they were saying that each section should have a lessons learned system for lessons that are only pertinent to, say, propulsion, that other people wouldn't be interested in. And they left it open whether it should be an automated system or even maybe just 5 items pinned to a bulletin board somewhere. Oh, here's 5 items.
So basically, have it more distributed at the working level.
At the working level and maintained and owned by that
Right.
working level, whereas the big lessons learned at JPL is managed by the Lessons Learned Committee. So this would be, and also that each section should have apprenticeships programs at that level, because we have mentoring programs, but apprenticeship is a little differently, where people are working full-time, 2 people are working full-time together.
Right. So there's a lot of different approaches, and I'm going to get to some questions, but did you have anything that you'd like to add to that in terms of the evolution, in terms of the different approaches around the people, the technology, or anything before we get into?
Definitely the people are key to it, and I think an understanding that some people are unwilling to share lessons. Maybe they feel that it's going to reflect negatively on them. But over time, they realize that after the sting is worn off, if it didn't quite go as well as they wanted to, that it's something that they should share. So one of the lessons learned from me is that people may not be willing to share something initially, but put some distance between that and a little bit of time, and then you can capture the knowledge and get it out there. So as we continue to do this more and more, the perception that you don't want to air your dirty laundry has kind of gone away, and more people are willing to do that.
Right, to learn to get better, which is in the complex work that we do. So one of the questions we have is foundational. How does the NASA knowledge community define knowledge management from the standpoint of knowledge in terms of NASA performance and its intended outcome and purpose? What's our definition of knowledge at NASA? Anyway.
Well, I think, there are many definitions of knowledge. And my working definition I'm using at JPL is that it's knowledge, or rather it's information leavened by experience that's used in project decision-making, flight project decision-making. So it's fairly narrowly focused.
Okay, Michael?
And again, our lessons learned definition was here's something that we've learned based on experience. And that's what really makes it knowledge worth sharing. Is somebody has learned this, having lived through it, and it's going to be an actionable situation to be able to implement in the future going forward.
Yeah, and we do have an agency. I mean, we have a location, km.nasa.gov, and it has a NASA knowledge policy. And so we do have a common definition that we argued over and came together with all the 10 centers and the mission directorates. And it's basically, it points to the fact that it's the day-to-day behaviors and activities that we do that impact the policies, the standards, and the requirements that we have in support of the missions and the people as ways of collecting the knowledge so that we're better in terms of the future. And that's more specific than that, but it goes into that. So we do have an agency definition in our policy document, which is in the km.nasa.gov.
But sometimes you could get the impression that projects and organizations don't recognize that knowledge has value past the initial application that knowledge was developed for.
Yeah, reuse.
That knowledge is there for reuse, so that we don't have to. Tim Adams in the audience mentioned earlier that we don't we don't always recognize that knowledge is reusable.
Okay. One of the other questions that we also have: does every center have a CKO and a lessons learned steering committee? And how does the CKO do? So yes, every center has a chief knowledge officer, as well as each of the 4 mission directorates. And one of the things I usually go around saying, we get a lot of questions about how do we find something, or how come this activity isn't linked closer to that. And partly it's because we've been starting up for just 2 years. And but go to the center organization. So at Kennedy, obviously the folks here have Michael. And so I've been here this week for some other activities, and people come up with ideas for capturing things and for communities of practice and for different ways to do things. And whenever they ask for funding, I say go to your local CKO. And at JPL, the same thing with David. So that is in place. And
that's at km.nasa.gov where you can find the CKOs?
Yeah, the whole listing of all the CKOs and their numbers, and so that's probably the most important piece of information. And what do? We typically come together and we prioritize issues that either we get from the senior leadership, we present to the senior leadership quarterly, to the agency's Program Management Council, the Associate Administrator, Robert Lightfoot, and sometimes we'll get guidance, like they wanted an agency policy a couple of years ago, and we worked on that as a community. Other times it'll come up from one of the things that we've heard from the workforce, from the engineering project community, is that search is abysmal at NASA, that you can't find things on the web. And so we now have a search working group that's being championed out of Johnson by Jeannie Engel and the team there, and we work as it together. So that's some of the things that we have that's going on. A question that I've also received has to do with how do we as a community, or how do you judge what content is really most prioritized, most important the diamond that needs to be really focused on and used. So what do you think about, there's so much information, there's so much content, there's so much, you can drown if you try to capture everything. How do we go about identifying what's most critical in terms of, let me start maybe Michael with, at Kennedy, how do you go about figuring that out?
And that is a difficult question. We get lots of information, and the question is this worth sharing? Is this something that we need to capture, or is it a one-off sort of activity? We do have a list of questions that we look at when we're looking at entering a new lesson. Is this something of a broad significance? Is it something that could impact future activities? Is it a safety issue? Is this something that we think the other centers or other people on center would benefit from? One of the things that we're doing at Kennedy, though, is meeting with each one of the directors and asking them specifically what are the critical challenges, what are the knowledge areas that we need to focus on. So as CKOs, we need to continually recalibrate what are the critical areas and look in those areas for what's coming up and what needs to be captured proactively.
Yeah, so the priorities come from the workforce and from the leadership. But again, one of the things I always say wherever I'm at is that go to the community, go to the CKOs and say something's critical so that it's updated. We've had a lot of activities. I mean, for example, one of the communities that was a mistake we didn't have involved originally was acquisition procurement. I was giving a briefing to the senior leadership, and Bill McNally, who heads up acquisition for the agency, called me and said, I'm really angry at you. And I said, okay, I figured I was in trouble with some procurement, so I was concerned. And he said, how come procurement isn't a part of this knowledge activity? And I said, well, we missed it. And so now that is part of the community, but sometimes it's finding from the community what we're missing. Finding diamonds and emphasizing the most important knowledge. How does that happen at JPL?
Well, that was the problem that I faced when I put together the JPL strategic plan for knowledge management, because do we want to try to capture all knowledge? Well, I felt we needed to prioritize that.
Right.
And how do you do that? Well, I could probably guess at a couple things that are important to JPL's ability to continue to do its primary mission year after in the future. And I could say, well, certainly entry, descent, and landing is important, because that's difficult to do. I mean, the Russians and the Europeans sent 21 mission to Mars, and they had a perfect record. They've all been failures. Everyone.
It's consistent.
Yeah, they're very consistent. So, and we've had some failures too at JPL where Mars is concerned. But I could say, obviously entry, descent, landing is that. But it's not really for me to say. I mean, I work for the chief engineer at JPL, but I'm not an expert in every discipline. So what we did at JPL was, the first thing, we went out to interview people and said, first of all, what knowledge is really critical in your area? And secondly, where are the gaps in capturing, retaining, and sharing that knowledge? And so what we did was we built a knowledge map with that. And with the knowledge map, the gaps in knowledge retention and sharing kind of precipitate out. This is what we need, this is what we have, and the delta was what we need to focus on. And so we're borrowing from other centers. Dr. Ed Rogers from Goddard came out in April to JPL, and he introduced a case study methodology to us, and also gave 5 case studies in addition to telling us how it was done, that about 85 people at JPL attended. And so we want to take that and develop some JPL case studies based on JPL missions. And use that. So that's
again, priorities are set
how we got in the diamonds.
by the workforce and what's most. Obviously, there's always technical reports, there's technical findings, there are mishaps, technical risk. Those things get identified. What's most important, becomes vital, for us, and it comes from both workforce as well as leadership finds. Sometimes external, entities or audits, have an impact on that. Interesting question says, do we have any examples where knowledge or lessons that were considered critical in the past we removed because they're not as important today. Do we see examples of, I guess, important information or new items that at one point were perceived to be critical, but now lessons now are not as important and they get removed?
Typically, we don't pull information or
Right.
entries out of the lessons learned database. We've had this database ongoing for quite a while, and I don't know if we're going to bump up on server space anytime soon. But we try and keep the information there. It could be relevant to somebody else coming up in the future. So we're not sure when it should be taken out. Just this summer, I had an intern working for me doing analysis of entries in the lessons learned database, and what we were able to do was look across the last 3 years some of the key topics that were tagged as entries in the lessons learned database, and that's the sort of activity where we can identify this as sort of a critical area and go back and say, what have we learned about those specific entries, and maybe we need to capture even more about those areas in the future. So doing analysis of what's in there is important, but we typically don't remove something.
So partly things stay there, and one of the, I know there's also concern, again, things that get raised at NASA, that they stay there in an ongoing fashion, because what may not be important, today may resurface again in 10 years. So.
Well, pilots have a saying, you start off your flying career with a full bag of luck and an empty bag of experience. And the trick is to fill your bag of experience before you empty the bag of luck. In flying, the problems you experience are pretty much the same that pilots have experienced throughout aviation. Bad weather, avoiding other aircraft, poor planning, and it's the same at JPL. We have gone through the LLIS looking at the JPL entries, and there were a couple that needed to be updated, but we didn't really find, there's nothing new under the sun.
You don't remove it, but you may update it and modify it.
Yeah. The engineering processes don't change that much.
Right.
And so no, we haven't.
Solid engineering, solid project management, you're building on that. One of the questions we have here is, we've talked about lessons learned, and one of the things, of course, is a community. So NASA formed the current knowledge approach, the Chief Knowledge Officer, 2 years ago. And one of the first things we did is we identified 6 categories of knowledge services. And one of the questions here is, besides lessons learned, what have we accomplished? What has the knowledge community accomplished in terms of offering different services and approaches in terms of knowledge exchange and sharing and being able to define? So what are some of the things that you point to? You mentioned case studies. You mentioned some of the different pause and learn activities. Any other things you'd mention?
Here at Kennedy, we have something called the Kennedy Engineering Academy, where we put on presentations after various activities to share the knowledge face-to-face. And we did a survey of the people at Kennedy and asked them what are some of the methodologies that they prefer to learn from. And on the top of the list was they would rather be in an auditorium, they'd rather be face-to-face, being able to ask questions and collect knowledge that way. But if they couldn't, a lessons learned system or a database is definitely up there in their desires. So realizing that we're in a technology-enabled environment, and maybe the tendency is to downplay some of the face-to-face methods of sharing knowledge. But I think one of our accomplishments is to recognize how important it is to still get people together, either right in the room or maybe with a distributed live situation, and share the knowledge that way so they can ask the questions like we're entertaining right now.
What are some of the things? You do a lot of stuff also.
Well, what I'm really excited about is what we call JPL Tube. It's something new. It was a partnership between JPL, Microsoft Research, and NASA IT Labs in the NASA Office of the CIO. And JPL Tube takes advantage of Microsoft Research Mavis technology that makes videos searchable. The completely text searchable based on the audio track.
Right.
And so it appears very much like YouTube in the look and feel. Anyone at JPL can upload videos to it. And any U.S. persons within the JPL firewall have access to it. But it really, I think, is potentially, and it's growing very fast, but it's really potentially a game changer because, if you make critical decisions, if you hold meetings that decisions are made, maybe someone writes a memo after it. But the memo doesn't capture everything that's said. It doesn't capture the feelings that were expressed
Right.
when that opinion was voiced. But what's the point of having thousands of hours of video? Because if you're looking for background on why a key decision was made,
Right.
why did we decide to set the value of that software alarm to off for launch? You could go to some PowerPoint slide that had the options, but someone took those options at a meeting and made a final decision. And why did they make that decision? Well, you'll never find that among thousands of hours of video, but here you have a capability where if you go to JPL Tube, you can search on it, you'll come up with a variety of videos. You click on one that looks like the right one, and it has a complete, as you're watching it, it's kind of like follow the bouncing ball. It has a complete text of it, and you can search at any point in that text. So,
Wow.
yeah, I mean, if you're looking
Better
for
tag and taxonomy and finding things.
yeah, I mean, if you're interested in how effective is alcohol for cleaning spacecraft surfaces for planetary protection, if you search on alcohol wipes, we had a seminar done by a guy who is a planetary protection specialist, and it goes right to that section where he's talking about how effective is alcohol wipes, what are the limitations on its effectiveness. So it's a very powerful tool, and we've presented it to a meeting recently of the other center chief knowledge officers, and they were actually very interested in it, and now we're looking at the possibility of NASA Tube.
NASA Tube, yeah. Matter of fact, I got an email pertaining to that a couple of days ago in terms of the funding, and so JPL Tube, and that may be NASA Tube, but it gets into the category, one of our 6 areas is search. Search and find and taxonomies, and we have a whole effort trying to work that, which is kind of monumental because NASA's been over 50 years, and there's so much information, so much knowledge. How do you find it? One of the things that also refer people to is, again, to that km.nasa.gov site, because in addition to the list of the CKOs across the agency and the cross-agency folks, there is that knowledge map which lists 6 different areas of efforts going on in terms of case studies, publications, in terms of online tools. Johnson has a phenomenal space shuttle console, which captures just so many of the lessons of shuttle over the 30 years. There's a lot of efforts in terms of networks, and so that will go through really a total list of the agency of what's going on. One of the questions that we also have is there an ideal way and time within a mission to capture knowledge? Does it happen at the start, before your project? Does it happen in the middle? Does it happen afterwards? What's the ideal time for capturing some of these lessons, and when should a project team do that? Thoughts?
There's probably a couple of places in the very beginning when you're looking for new information, capturing your thoughts and your ideas, and you're talking about the decision rationale. And then at some of the key decision points, reviews, might be a good time to do a pause and learn and capture knowledge. And I think a lot of our requirements documents point to the decommissioning phase and the end phase, but I wouldn't wait until the very end of a project to capture the knowledge. So ongoing, maybe 3 or 4 different points to stop and think about what's going on. And if you capture some thoughts early on, when you get to the end, maybe you revalidate those, or you decide, well, this wasn't as important as I initially thought. But still, a couple places within the life cycle,
Right.
It's important to program those in, put that in your project schedule to make sure that you do that.
Right, and we've had, one of the successful missions we had that was led out of Goddard by Dave Mitchell was Maven, and there's been a lot of discussion about why it was successful. But in that case, as a manager, before he started the mission, he went out, I believe, to JPL to talk about some common missions, working with the industry partners, things to look for, and then he would have different stopping points to have just lessons learned discussions. And then afterwards, they've done a tremendous job of capturing what they've learned and sharing that. So it happens at any point in a mission.
Yeah, yesterday I flew out here, and I was stuck in an airplane seat for 5 hours.
So you didn't fly yourself?
No, I didn't fly myself. No. So you're sitting there in the seat, and you tend to pause and reflect. And I started thinking about things in my life that you don't usually think about and partially because you're stuck there, you have the time, and partially because you've taken yourself out of your usual context. And so out of your daily concerns. And unfortunately, a spacecraft flight project doesn't sit in an airplane seat, and it's very fast-paced. You have to get the hardware to launch, then you have to, you may have a 10-year mission after that. And how do you get them to pause? I mean, there's no pausing. It's 100%
right.
Straight ahead. So we actually did implement Dr. Ed Rogers' Pause and Learn that he pioneered at Goddard. We had the advantage in that we had a monthly meeting of project managers. So I suggested to our associate director for flight projects and mission success, why don't we try this Goddard innovation of Pause and Learn? We'll take 15 minutes at the end of the meeting, and a project manager will stand up, and he or she will talk about a problem on their mission, how they approach solving the problem, maybe what they would have done differently if they could have done it over again. And that turned out to be rather, and it's not for attribution, and PowerPoint is not particularly encouraged because we want storytelling here. Storytelling is very powerful. The cavemen around the fire where the elders are telling stories to the young folks, and generally they have a point. Okay, you see I'm missing an arm? Don't pull the tail on the saber-toothed tiger.
Right.
So we've been holding these pause and learns, and we've had about 10 of them so far, with a different project manager each time. Another thing that same associate director for flight project missions support asked me to contact project managers about 2 weeks before a major project milestone. PDR, CDR, the end of mission, pre-flight review, and suggest that they hold a lessons learned session discussing lessons learned over the previous phase.
Right, and so there's a lot of activities. And again, if the teams and the project managers, there's a lot of different ways to approach it. And obviously the pause and learns have been done for many years. Military after action reviews are the same approach, same technique. We have a question here that gets a little bit specific, and it's about shuttle. So I'll have to defer this one to Michael. And the predictions of operational cost or cost of the shuttle, where obviously we're significantly off. And most USA contractors have different theories and insights in terms of what went on and how again we were so off on the cost. The question is, would this be a valuable thing to explore and to understand? And I guess it's do we do anything pertaining to learning that lesson?
Absolutely. I know that as the end of the shuttle program was coming to a close, we did make a concerted effort to get some of those lessons and to put those in the lessons learned database in LLIS. So if we go back and search that, there's some information related to that. But if there's more information that we can learn from it, it's still not too late to capture that as we transition to other projects here at KSC and across the agency. That would still be a resource for people to be able to pull on if we can have a session on that and put together an entry, maybe a whole workshop around cost projections and how we get better and better at NASA at defining that.
And we did actually, and you're part of sponsoring the sessions we did several years ago on lessons of 30 years of shuttle, where we brought in the initial engineering designers and management, and they talked for 3.5 days about what were the things that really we don't want to forget as we do future missions, and the things we don't want to forget from the standpoint of mistakes we've made. And it was also not only capturing it, but it was also with young professionals and with folks who were different stages of experience. So we definitely do those kinds of things. We've talked a lot about mission-related lessons. Do we also look to capture non-mission, for example, infrastructure, type activities?
Yes, we had an incident a few years ago where the Southern Edison substation near JPL tripped, and all the power was shut off to JPL. So you have all these systems that are supposed to respond. For example, that exit sign over there, if all the power goes out at Kennedy Space Center, we would expect that exit sign to be lit because they're supposed to be lit when there's no power on. They have backup batteries. We expect alternate power systems, generators, to come up automatically. Well, it turned out that they didn't exactly. Some of the exit signs didn't light, and we had other problems. And one of the problems is, how do you test for something like that? The only way really to test for it would be to have an authentic test. A simulation would be to shut off all power to JPL. You don't really want to do that because, you have flight computers that are running, recording downlink data from a mission, and if you were to shut off the power, they might come up, but would the air conditioning still be maintained to keep them cool? So yeah, we had that. We had a major fire several years ago, the station fire at JPL, that actually resulted, it was 20,000 acres, I think, that was burnt, and several firemen lost their lives, and it came just to the fence of JPL. The ridges just above it were aflame. And so we discovered some very interesting lessons from that. In February, they decided they needed to clean the cooling tower. And so that they could take some annual taking leaves out of it and so forth, maintenance they do once a year. So they shut down the coolant, and as a result there was a test of some radioisotope thermoelectric generator materials that had been running for a couple of years. And those 2 years of tests were terminated because of flooding when that coolant tower went out. As it turns out, they were just about to end the test anyway. But so yeah, we do look at facility issues.
Yeah. So the answer is yeah. It's the knowledge that's critical. I think would agree to the success of NASA, the missions, the work we're doing, and to the organization.
Yeah, I know JSC put in a lesson about the response to Hurricane Ike recently, actually, and they coordinated that with Stennis and Kennedy as well to talk about what are some of the things that they didn't do or they learned in trying to shut the center down and bring it back up. So we have infrastructure lessons in there, and the previous question about cost. I know the James Webb Telescope did a lessons learned on how they were calculating the cost. And some of the lessons learned they had about that process. So the lessons learned that we do span the spectrum of almost anything.
Right. I think you had a lesson learned on our roofer on the ONC.
Yeah, we do have some mishap lessons that happen, and we try to learn from those as well.
So we are, amazingly, we're down to like 3 minutes. So we need to get towards the close. We'll miss a few questions, but again, we can get questions to you. But the final question I'd like to ask really, I guess, is career advice. We have a lot of young professionals who join NASA, and I guess one of the questions asked for each of you is, what advice would you give to someone who's starting out, who's interested in having a successful career at NASA, and perhaps in knowledge and lessons learned? How would you go about doing it? What's the key advice you would give? David?
Well, I had the opportunity a year ago to hire someone right out of graduate school, and she joined a women's professionals organization at JPL. And that's proving very useful to her because not only for networking, but to learn the JPL culture. And then there's a fellow at JPL. I have to say maybe he's one of our crown jewels. He's been working at JPL for over 50 years, and much of the institutional knowledge at JPL is in his head. So what he does is he always eats every day at lunch. Takes lunch at the JPL cafeteria, and he makes sure that the seat across from him is empty. He sits at a table that has empty seats around him. And the idea is that people will sit down there and engage him in conversation and ask him questions, because he has this wealth of information, and some of it isn't just data. Some of it, you have to get the full flavor of it, storytelling. So I would encourage young professionals, when they see someone like that at the KSC cafeteria, grab a seat next to them, introduce themselves, say hi, I'm new here, this is what I'm doing, and ask the guy a couple questions.
So networking,
someone with gray hair.
Networking and mentoring, key things. Michael, final word?
I can echo that, and also I would say the lessons learned process has been involving for a long time, so perseverance is to keep at it, to keep trying and trying and trying again. Sometimes young professionals will come up with an idea and put it out there and nobody buys into it, but if you come back at it a second and third time, it's gonna get out there. So don't give up with some of those ideas, to keep pushing those out there, and eventually they'll take root.
Yeah.
And maybe sitting across from the guy in the cafeteria, you can ask him some questions on how did you make it, and who are some of the other people I need to talk to get that idea implemented. So the networking thing is definitely a benefit in your career as well.
Yeah, and NASA's an organization that always has challenges and is always working on things. What I've seen is if you're interested in something, go to the folks who are working it and volunteer, get involved and work it. Again, we've run out of time for this session looking at knowledge and lessons learned. Probably should have done 2 hours. Maybe we'll come back again. Want to thank Dr. David Oberhettinger, Chief Knowledge Officer of the Jet Propulsion Lab, Dr. Michael Bell, Chief Knowledge Officer of the Kennedy Space Center, for your insights. Want to thank the folks here at Kennedy and leadership for allowing us to come and capture this. And hopefully you'll support us in future learning activities. So thank you.